Hey everyone, thanks for joining, and we're going to spend a little bit of time here talking about saving the world with geospatial data. My name is Chad, and I'm the Geospatial Analytics lead for Google Cloud. I'm also a product manager inside of data analytics. What we're going to do with the next little bit of time here is talk about use cases, primarily that our partners have developed tools for that relate to climate change and relate to sustainability. Those are sections 1, 3, and 4. Then in section 2 here, I'm going to talk a little bit about the products that these partner tools are using to achieve the results and the user journeys that they do. Okay, so now that you know what we're on about, let's go ahead and dive into it. So obviously, sustainability, dealing with climate change are huge topics now, like not just for data analytics, but for people on the planet and the survival of people on the planet. And so the use cases that we pulled here are all very important and significant, but they're looking at specific elements of this incredibly broad problem. So we'll start with sustainable supply chains and a tool called Tracemark that our partner NGIS has developed. Now, Google and NGIS are working on several different initiatives across CPG, consumer packaged goods sustainability, from measuring carbon emissions to sourcing raw materials responsibly. We don't have time for all of this in this session, so we're going to focus on raw material sourcing. So for the next couple minutes, let's assume that we all work for a company that sources palm oil. I didn't know anything about palm oil until I started this work. Palm oil is in everything from chocolate to frozen meals to toothpaste and shampoo. If you look at the, go to your pantry and grab, a packet of one of these things and have a look, and you'll find, the hydrogenated palm oil or palm oil explicitly in the ingredients list. I had no idea it was such a widespread commodity. Now, palm oil is obviously in huge demand from huge portions of the world. It is sourced generally from equatorial regions. And so you can imagine the supply chain from all of these different sourcing regions to your mill and distribution centers, maybe in Europe or something like that, and then distributing it to customers all over the world. So your supply chain is obviously global. What that means is your supply chain crosses geographic boundaries, time zone boundaries, political boundaries, socioeconomic boundaries. And so things that are important to you wherever you are, say in Brazil or Argentina or Europe, things that are important to you are going to be different than the things that are important to people that are sourcing your material. And so it's a very complicated and very large, literally large problem. One of the questions you might be asking yourself to help manage this is, what is the percentage of deforestation-free palm oil that I can get from my vendors? And so which vendors have the best records for deforestation-free palm oil? Now, this is obviously a global problem, so you need global data to address it. You need local data to address it because you're going to differentiate between supplier A and supplier C. And so NGIS's solution called Tracemark pulls together a huge number of data sources to address this. The three primary categories are these: customer, Google, and third-party data. Customer data includes things like, where are the specific locations of my palm oil suppliers and the palm oil mills? Google data are things that are available, say, in the Bigquery or the Earth Engine public catalogs. This image here is actually a literal heat map showing surface temperature of the planet, as a function of time. So, weather data, satellite imagery, land cover data, fire alerts, etc. There's a lot of material like that inside of Google's data stores. Third-party data for things that can't be answered by the things inside of Google's data stores, maybe much higher resolution satellite imagery to really get into the nitty-gritty of what's going on at a particular mill. So speaking of the map of mills or sources, so in these little yellow lollipop icons around this map, these are all sources of palm that then gets transported to the palm mill, which is in red there. And then that red trace that goes out to the north of this picture, that's shipping it out to the processing plant that's maybe up in the northern hemisphere. And so if you're interested in the deforestation impact of all of these all of these POM sources, you need to be able to look at the, this area both en masse and in specific. So let's click in and look at the specifics. So this is the user interface for Tracemark, and it's powered in large part by Earth Engine. And what's going on in this part of the animation here is that the image on the left of that vertical white line is June 2016, and the image on the right is 2017. As you sweep it across, you can move backwards and forwards in time. And so you can see here from this animation that a lot of deforestation has happened in this 18-month period. Now, you can create this view for humans to understand, which is what that sweep is for, or you can use machine learning algorithms to detect it algorithmically so that you can then export these areas of highest impact of deforestation, to a downstream processing engine like Bigquery. And so Tracemark, like I said, pulls all of these different data sources together to give you both global and local impacts in deforestation around your mills, which is going to be useful to you to help your mills with high deforestation impact to say, hey, here's how we can help you, reduce your deforestation impact, or in the best case, eliminate it totally. So Tracemark uses Bigquery and Earth Engine to great degrees here. Let me speak a little bit about those products and how they fit into the Geospatial Analytics suite offered by Google Cloud. So our goal at Google is really to enable geospatial analytics to go through the same evolution and renaissance that on-prem analytics is going in the migration to the cloud. And by migrating to cloud infrastructure, we can really release geo workloads from those legacy constraints so that you can do much bigger problems, global problems, instead of local ones. To enable that, we've crafted our offering really on 4 technology pillars. And the two on the left here, Bigquery and Earth Engine, are more or less aimed at the 2 types of data that are most prevalent inside of geospatial workloads. So Bigquery is Google Cloud's enterprise data warehouse, and it has outstanding support for geographic data types and functions. And so what that means is it will handle vector processing, so points, polygons, line strings, incredibly well. Earth Engine is a similar platform, so storage, compute, both separated and incredibly scalable. And Earth Engine is focused on raster processing, so pulling insights out of rasters or images. Vertex Ai is Google Cloud's AI platform, and that has amazing functionality for notebook experiences, as well as, and those notebooks can call any of these other products, so you can do all of your data science work in one notebook, even if it spans multiple products. And then once you develop your models, Vertex has a number of capabilities around managing models and publishing them so that you can have a scalable endpoint with which to do predictions and models. And then lastly, the Google Maps platform, APIs. Once you've got those predictions that you're going to deliver, you want compelling visualizations or compelling interactions for your folks. So the GMP APIs are perfect for that. Focusing on Bigquery just for a moment, Bigquery scales incredibly well. So you can do big queries, sorry about that, over a lot of data really fast. And we find that performance is a real enabler here. So in this example, a simple implicit join query, each of these tables has millions of rows. The output itself has 4.5 million rows. This query runs in 12 seconds in Bigquery, and on a beefy PostGIS instance, it can take several hours. We see results like this, or acceleration results, speed up results like this all the time inside of Bigquery. And so if you're doing the good work of managing, or like sustainability management or climate change analysis, if you're doing that good work, you can do it a lot faster and a lot more of it if you're using a platform that speeds your queries up by this, several orders of magnitude. Customers in a variety of different verticals are using Bigquery. A common use case inside of retail and telco is doing spatial aggregation. So counting how many, for telco, like counting how many phones are in a particular area so that you can make sure your network coverage the strengths of your network coverage are correlated to where people are going the most often or where people are making calls from. Inside supply chain and transportation, we talked about supply chain a little bit. Transportation, this map here actually shows hazardous driving behavior as a function of weather data. Our partner and customer Geotab provided that analysis. Public sector and research, we saw a huge uptick in geospatial usage around COVID, as municipalities and agencies around the world were trying to create maps to help their residents and constituents understand which areas were having outbreaks, which ones weren't. This map here actually comes from our customer and partner Aclima and shows air quality as a function of location. And then sustainability in agriculture, we're going to talk about that one right now. So our partner, Wozer Labs, has a number of capabilities across sustainability, some including supply chain transparency that we just talked about from NGIS to methane and carbon emissions. We're going to talk specifically about crop sustainability. So now let's pretend that we are a farmer or an agricultural manager, and we want to see what the impact of our specific agriculture fields are having in a variety of different ways. And so we would log into the WOZA application, which covers, you can see in the green text there, 12 countries at the moment, hundreds of millions of hectares of land. And as a user here, you can outline where your fields are, either by clicking on the UI or by loading up a shapefile or a GeoJSON file. You select the layer of information you'd like to get out of it, and WOZA has pre-computed a number of different metrics for you so you can have an interactive experience. So you might be looking for the biodiversity impact layer, or which crop species is growing on the fields that you've selected. And crop species is interesting because these crops have different spectral signatures that are detectable from satellite images. So WOZA knows how to differentiate soybean from corn, right? Because they look different to different bands in the Sentinel-2 imagery. As a farmer user, you don't have to know what the spectral signature of soybeans are. You just have to say, hey, I'm interested in where the soybeans are, and WOZA will take care of that for you. And if you're a soybean farmer, you can look for the fields that have soybeans, and then in those fields, you can look at the biomass index and say, you know what, this portion of my field has a lower biomass than I would like it to. I'm going to update my fertilization plan or my irrigation plan or my seed planting plan so that I can try to help that portion of my field do better and thus get better yield. Now, WOZA, to make this application happen, WOZA has done a fantastic job of knitting together a whole bunch of different elements of the Geospatial Analytics suite. They use Earth Engine to process those images and, for example, do that spectral comparison to differentiate corn from soybean. They export those data to Bigquery, and they've computed machine learning models to combine them with, say, weather data. So you can actually say, okay, if you've got this many hectares of soybean and the weather last year was really good for soybeans, then we know, say, Argentina is going to have a bumper crop of soybeans next year. They then export that data to Cloud SQL, App Engine, and render with Google Maps so that their customers can have an interactive experience inside of App Engine. So they've done an outstanding job pulling all of this together. I'd like to switch gears a little bit, and we're going to move from agriculture into infrastructure. And so Cardo, who's been one of our most innovative geospatial partners over the last several years, has created a climate insights engine. And again, it spans a number of different environmental impact factors. We're going to focus here on erosion. So imagine again that we work for the Hawaii Department of Transportation. We have about 2,500 miles of highway to manage, and about 500 miles of that is at risk due to erosion or sea level rise. And so what we want to do is we want to have a common platform where we can surface insights to a variety of constituents, whether they are the people that elected us to be in office, or whether they are neighboring counties or cities or vendors. And so what we want to do is understand which roads are at risk from erosion. And so Cardo's climate engine or climate insights uses Earth Engine to create erosion models. Those erosion models are then exported to Bigquery, where they're served in an interactive user interface like you see here on the bottom right that communicates which highways are most at risk. They can then combine it with their own planned data to say, these are the most at risk highways or roadways, whether that's due to sea level rise or erosion or landslides from, abnormally high precipitation. And that way they can communicate, like, we're going to do this road first, this road second, and try to keep all of their constituents informed and aligned. And to be honest, it's that concept of keeping constituents informed and aligned that I actually think is one of the most impactful for any of these solutions. We'll touch on that one just later, but first I wanted to recap the products that were being used here. At Google, as I mentioned, our goal is to release the workloads, release the constraints of the past for the workloads of the future. And these products are incredibly good at doing that. And as a matter of fact, all of them are differentiated on their own. And when you bring them together into a suite, it's kind of like differentiated to the fourth power here. And so when you enable people to do this kind of work at the scales that we're doing, they can develop an immense amount of insights from the analytics, so the left portion here. Great, that's really important. To really generate collaboration and action, though, you have to be able to communicate a common understanding, or have to be able to generate a common understanding of what's true. And so that's where taking these insights from the analysis and then producing these compelling visual environments where folks can look and explore and understand kind of on their own time is what generates that community engagement. And so, like, if you imagine, the state of Hawaii, like, they have their communities that they need to engage. And you think about the palm sourcing example, right? These communities go from, small communities in Indonesia that are harvesting palm fruit to, large communities, like to the, call it the state and federal governments in Indonesia to, to governments that span, governments in other continents. So to get all of these disparate sets of people to be, to understand the impacts and to agree on a common source of action, you really do need to have a visualization platform. You have to be able to communicate what the state of the truth is, at least as best you know it. And that's where I think data analytics has a unique role to play in this area of sustainability and analyzing climate impact. So if you found that interesting, I've got a couple links for you here. You can go and read a little bit more about what we are doing in that first link, what our partners are doing in that second one. The Google Maps platform recently launched some really awesome 3D visualizations. So if you're into goo.gle, that third link is for you. With that, thank you very much. My name is Chad Jennings.